This video covers how we compute a quantity called the covariance. It's the basic building block underlying all computations in regression models. We'll work through this simplistic example just to make sure we understand the basics. We're looking at, for 5 of my imaginary friends, the number of hours of sleep the night they got the night before the Knowledge Festival, our X variable, our independent variable, and their grade on the Knowledge Festival, the Y variable, the dependent variable. And we're looking to find the covariance between those two variables. I'm going to ask you, can you find the variance of those numbers? Those numbers are the hours of sleep. Can you find the variance of those numbers? You should be able to. And if you need to go back and review standard deviation computations, do so now. Exit out of this video, go review that computation, then come back here. But we just worked through this example if you did that slide deck. Now, if you can do a variance, and you can also find the covariance, because it's exactly the same, only different. A variance measures how far we are from the middle on one variable. A covariance does it jointly for 2 variables, but that's the only real difference there. And so here are our data again. Average X, average amount of sleep, is 4 hours. Average grade is a 70. So how far are we from average? Anastasia here, 6 hours sleep, 4 was average, so she's 2 hours above average. Balf, with no sleep, shame on him, is 4 hours below average, and so on. We do the same thing for the grade variable. Anastasia's 90 was 20 points above the average grade of 70. Balf's 38 is 32 points below the average grade of 70, and so on. Now, if we were finding a variance for the X data, we would take these numbers and square them. We would do X times X. We're going to do the same sort of thing here, only we're going to take X stuff and multiply it by Y stuff. So 2 times 20 is 40. Minus 4 times minus 32 is positive 128. Remember that to find a variance, we would take differences, square them, X times X, and then average them, air quotes, by adding them up and dividing by sample size minus 1. Same idea here for the covariance. Take those differences from the middle, data minus the mean, multiply them, only now it's X stuff times Y stuff, but we're still going to, air quotes, average them by adding them up and dividing by sample size minus 1. So X times Y, add them up, divide by sample size minus 1, our covariance is 70. Back on a slide with all the data, we're taking the data, subtracting the mean, X times Y, take those products, add them up, divide by n minus 1. Our covariance is 70. In picture terms, if these are our data, we're looking at how far the data are on average from the middle. The middle being 4 hours of sleep, grade of 70, this point right here being the middle of the data. And so Anastasia, 2 hours above average in terms of sleep, and 20 points above average in terms of the amount of grade that she got, and so that area is representing a distance between this point and the middle. Similarly for Balf, he's 4 hours below average and below average in those distances. And we're taking for each point those distances from the middle and, air quotes, averaging them. So here's another example. Number of customers at a small retail outlet, sales at that outlet. I'm going to ask you to take a minute, pause the video here, work through and find the covariance for these data. You should get a 133 and a third. Okay, pause the video, take a minute and look at this. Okay, so here are the computations. X variable is customers. We believe that customers drive sales. Average number of customers was 5, so we look at how far we are from 5 for each of the time periods. The average of the sales data is 100, 70 minus 100. We do X stuff times Y stuff, minus 1 times minus 30 is positive 30. Positive 3 times positive 70 is 210, and so on. Add them up, divide by n minus 1, our covariance is 133 and a third. Again, if you can compute a variance, and you can compute a covariance. It's basically the same thing, only in 2 dimensions. And it's the basic building block for our computations of regression models.